Hello, welcome to section 11.1, where we look at inference about two population proportions. Now, in chapter 10, we looked at inference about one population mean, okay, but then not the one population proportion. But the idea we use over here is just an extension of what happens under the one population case to two population. But over here, we are looking at proportions, okay? And it's not much of a difference. Now, even though I provide the formula for calculating the test statistic, the p-value, in the slides, okay, I'm going to teach you the calculator steps for doing that. And actually, that should be our focus, how to use technology to get these results. Because it can get quite cumbersome if you are computing these values mechanically. Okay, so I show you the calculator steps in this very video, and then in terms of the start crunch steps, they are posted in the slides. Okay, so you can look at that and practice it and use that for your project. Yeah, so the start crunch approach or steps will be necessary when you are doing your project. Okay, all right. So we look at the first question. Now, whatever happens here, we are assuming that the populations that we are considering, the two populations, are independent of each other. Okay, so we need to know what independent sampling is and what dependent sampling is. So simply, a sampling method is independent. So you have two independent samples, or a sampling method is independent when the individuals selected for one sample do not dictate which individuals are to be in a second sample. Okay, so take for instance, we are sampling 100 students from CMU. So let's say we want to know the proportion of students who own cars. Okay, so we are sampling 100 students from CMU, and out of that sample, we determine the proportion of them that own cars. So that will be our first sample. Then we go to Mid-Michigan College and also sample 100 students, right? Now, when we do that, we have two independent samples, okay? So whatever sample we choose from CMU doesn't influence the sample we are choosing from Mid-Michigan, okay? All right. So that is about it. And that is about independent samples. So a sampling method is independent when individuals selected for one sample do not dictate which individuals are to be in the second sample. Now, for the dependent sampling, so a sampling method is dependent when the individuals selected to be in one sample are used to determine individuals to be in the second sample. Okay. And sometimes we call these dependent samples are sometimes called matched pairs samples. Okay? And it is possible for an individual to be matched against himself or herself. So what happens in dependent sampling is, let's assume that we want to know the age difference between, so let's say we want to know the age difference. Yeah, so, okay, let's say, for instance, we want to know the reaction of people to a drug. So before taking the drug and after taking the drug. Okay, so let's say we want to find out their temperature. Yeah, so what we can do is, if we sample 10 people, right, and then we take note of their temperature before taking the drug, okay, then we are having 10 results, right? So before taking the drug, 10 temperature counts. And then after taking the drug, also taking 10 temperature counts. Now, those temperature counts will still be on the 10 people that we are looking at. Okay, so we have two different samples. The very first one being temperature before the drug, and then the second one, temperature before the medication. Okay, and that gives us dependent samples. So these samples whatever we took the temperature on the first time or the second time is influenced by whomever we took the temperature on the first time. So that gives dependent sample. All right. So coming to the very first question in this video, it says assume that the samples were obtained independently using simple random sampling. Okay, so you have two different populations, and then the samples are taken from them, where one sample is not influenced by the other sample. And the researcher wants to test whether the proportion in the first population is greater than the proportion in the second population. So P1 is greater than P2. So remember, P is the representation for population proportion. So P1 being the proportion of population 1, P2 the proportion of population 2. So the sample data. So X1, N1. X1 is the number that has a characteristic of interest in population 1. And then N1, the sample size of population 1. Then X2, 351. And then N2, 593. Now conduct the test at the alpha equals 0.05 level of significance by determining the null and alternative hypothesis, the test statistic, and the p-value. So this, when you go through the step, is like step 1 to 2, right? Step 1 to 3, yes. So the very first question, the null and alternative hypothesis. So remember, the null hypothesis always has inequality in there. So this means simply P1 equals P2. Then the alternative hypothesis is what we want to test. So we want to test whether P1 is greater than P2. So it means that H1 is P1. H1 is given as P1 is greater than P2. Then B, we want to find the test statistic. Now, to compute the test statistic by hand, that is given by the formula I've written on the screen. So Z0 equals P1 cap minus P2 cap, right? The cap indicates that these are the sample population values, right? Over square root of then all that you have in the denominator, right? Now, the P cap that you see in the denominator is given as X1 plus X2 all divided by N1 plus N2. Okay, so that gives the computational way of the mechanical way of finding the test statistic. But then we want to use the TR84 step. Okay, so the steps are outlined in this very slide. So the first thing you do is you press start. So you look at the steps. You can pause this video and try to go through getting these values. Okay, so press start, highlight tests. Okay, so you press start and then highlight test by moving to the right. Then you go to option 6, which talks about 2 prop Z test. Okay, so 2 proportions Z test. And then you enter the values. Now when you press that 2 proportions Z test, you enter the sample values. Okay, so you specify X1, N1, X2, and N2. In this case, 368, 541 for X1, N1, and then 351 and 593 for X2, N2. Then you highlight the relationship between P1 and P2. Okay, which is in the alternative hypothesis, and in this case that is greater than P2. So P1 is greater than P2. And then you go to calculate. So you press enter, and then it gives you your result. So press enter, and then it gives you your result. Now what result do you see coming out? So you see Z, okay, as one of the values, and the Z over there indicates the test statistic, and Z is 3.08. And then you also see P cap, which we would have calculated by X1 plus X2 divided by N1 plus N2. And then we're also given P1 cap and P2 cap. Now what is of interest to us in this question is 3.08, which is the test statistic. Now one other value that you see over here is given as P equals 0.01 0.001 approximately, and that is the p-value. So you realize that this calculator step actually gives you the result for B and C. Okay, so for B and C, so the C, the p-value is approximately 0.001. All right, so it looks simple when you are using software to do it. Okay, all right, so we go on to the next question. It says, in a randomized double-blind clinical trials of a new vaccine, monkeys were randomly divided into two groups. Okay, so you have two groups, and then subjects in group 1 received a new vaccine, while subjects in group 2 received a control vaccine. So you have two separate groups consisting of different monkeys. Okay, now after the second dose, 131 of the 442 subjects in group 1 experienced drowsiness as a side effect. After the second dose, 23 of the 103 of the subjects in group 2 experienced drowsiness as a side effect. Thus, the evidence suggests that a different proportion of subjects in group 1 experienced drowsiness as a side effect than subjects in group 2 at alpha equals 0.05 level of significance. All right. So when you look at this situation critically, you realize that we have two independent samples, okay, where the sample size for the first group is 442, for the second group is 103. So this satisfies the kind of situation we are looking for in this very section, okay. So the first question, we want to determine the null and alternative hypothesis. So the null hypothesis always is a equality, so P1 equals P2. So proportion in population 1 equals proportion in population 2. Now, what are we testing? It says, does the evidence suggest that a different, okay, so the word different is key over here. So does the evidence suggest that a different proportion of subjects in group 1 experience drowsiness? So because of the word different, that is why we go for not equal to. So the alternative hypothesis will have P1 is not equal to P2. All right. Then to find a test statistic and the p-value, we use our calculator again. Okay. So we go to stats, then we go to tests, and then go to option 6, 2 prop z test. Then we enter that and then enter our values for x1. X1 is 131, N1 is 442, X2 is 23, N2 is 103. And then we specify what is in the alternative hypothesis. In this case, it's not equal to P2. And then we hit the hit calculate. We highlight calculate and press enter. And then the output that we have, the very one which is of interest to us for B, is Z. And Z is approximately 1.48. 1.48. Okay. Other values that are given to us are the P1 cap, P2 cap, P cap. Okay. Now, you realize that there is also a P over there. Now, this P is a p-value, and that is what C is asking for. So the p-value is approximately 0.138. Okay, so it is very important that at this point you pause this video and go through the steps yourself to see what is going on. Okay, so to be sure that you can also reproduce the same results using technology. All right, so this is where how far technology can help us. So with D, we state the decision and the conclusion. So in this case, it's always simpler to use the p-value approach. P-value approach means you are comparing the p-value with alpha. You are comparing the p-value with alpha. So remember, alpha in this question is 0.05. So the decision will be reject H0 if p-value is less than alpha. This is always the decision regardless of whatever test you are dealing with. So you reject H0 if the p-value is less than alpha. Reject H0 if the p-value is less than alpha. Okay, and what happens here? What is our decision? Since the p-value, which is 0.138, is greater than alpha, we do not reject H0. Okay, so if one doesn't hold and the other holds, so either you are rejecting H0 or you do not reject H0. Now we do not reject H0 since the p-value is greater than alpha. And what is our conclusion? We conclude that there is sufficient evidence. Okay, so I think there is an issue here. So this should have been there is not sufficient evidence. So there is not. Okay, so I just noticed it. I'm going to update that in the actual material. So we conclude that there is not. Yeah, so there is not sufficient evidence that a different proportion of subjects in group 1 experience drowsiness as a side effect than subjects in group 2 at alpha equals 0.05. Okay, so because we do not reject H0, it means that there is not sufficient evidence to conclude whatever is in the alternative hypothesis. Yeah, so I just noticed this, so I'm going to update that in the slide that I posted earlier on. Okay, so we move on to question 3. It says construct a confidence interval for P1 minus P2 at the given level of confidence. Okay, so now what happened is that in what we saw earlier on, okay, where we had in fact what is happening over here is just an extension of what we see from the hypothesis test. So hypothesis test is one way of statistical inference. Confidence interval is another way, right? So confidence interval is interval estimation. Okay, so P1 minus P2, right? How do we find the confidence interval for that? Formula-wise, we have the lower bound, which is giving us the point estimate. So the point estimate in this case is P1 cap minus P2 cap minus, then all that you have on the right gives you the margin of error, right? Then for the upper bound, you have plus. That sign changes to plus. Okay, I guess this looks familiar in terms of the construction when you compare what we did under chapter 9. Okay, the only thing that changed is now we are looking at two populations or two proportions. All right, but still in this case, we want to use software to do this computation. Okay, so either you use StatCrunch or the calculator. And then using the calculator step, you go to Stat and then hit Tests and go to option B, which is 2 prop Z int 2 proportion Z interval. Okay, then you'll be asked to specify the values. So 2 proportion Z interval, that is option B. And then you specify your X1, N1, and then X2, N2. So for question A, it says X1 is giving us 368, N1 541, X2 421, and then N2 593 at a 90% confidence. So specifying that, we have those values put down, and then our C level has to be 0.9 because it's 90% confidence. Okay, it's always a decimal value between 0 and 1. So it has to be converting the confidence interval to 0.9. And we have our results coming out, and you realize that the first output is in parentheses. Okay, and that gives us the lower bound and the upper bound. So lower bound is negative 0.0748, upper bound is 0.0153. Right? And values that we would have calculated by hand, that is the P1 cap and P2 cap, are given to us by this calculator output. All right. Then B says X1. So when you are given X1 as 109, N1 475, X2 78, and then N2 325 at a 99% confidence. So still going through the process, you press start, go to tests, and then option B, 2 prop Z int, right? So you specify the X1, N1, X2, N2, and then the C value in this case is 0.99. So we hit enter, and then we have one output. We have some output coming out. The very first output is the lower bound and the upper bound, right? Negative 0.0892 and then 0.06817, right? So that gives us the confidence interval for B. All right, so this ends it for section 11.1. That is the inference about two population proportions. So either you are doing hypothesis testing or you are finding the you are estimating. So either point estimate or the confidence or the interval estimate. An interval estimate means you are finding the confidence interval. Okay. All right. Thank you.